Good day, everyone. I'm Christy Joy Villarmino, and I will be presenting to you my topic, which is all about climate predictions. So, first, what is climate prediction? So, it is different from daily weather forecast. So, instead of saying, will it rain tomorrow? Climate prediction looks months or even years ahead, predicting bigger patterns like a hotter summer or a colder winter. Let's move on to the next slide, which talks about why is climate prediction important. So it is important because it helps government or communities to prepare for disasters such as floods or droughts. It allows farmers to plant their crops according to expected rainfall. It supports infrastructure, dams or roads. And also, it informs policies to adapt to or reduce the effects of climate change. Now, let's talk about the methods in climate predictions. So, we have the methods, which is the dynamical model and the statistical model. So, dynamical models are very complex. They are based on physical laws of nature, like thermodynamics and fluid dynamics. This model divide the Earth into 3D grid and calculate how heat, air, and water move over time. Because they are very detailed, they need supercomputers to run. Examples include general circulation models or GCMs. For the statistical model, so it is a bit simpler. They'll look at historical data. For example, if we see that past warm ocean temperatures cause heavy rains, we can predict the same in the future. However, they can struggle if conditions change in ways we haven't seen before, like under extreme global warming. Next is the key influences on climate prediction. Several influences, several factors influences climate predictions. One of these is the greenhouse gas concentrations are important because they trap heat. Solar radiation also varies slightly and affects Earth energy balance. Volcanic eruptions can temporarily cool the planet by blocking sunlight. And ocean cycles. Let's talk about the challenges and climate predictions. So climate predictions isn't perfect. There are uncertainties because models are based on assumptions. The Earth's climate naturally varies unpredictably at times. In some regions, data is limited, especially over oceans or remote areas. Also, feedback mechanisms like how clouds behave are very complex and hard to simulate. Those are the few challenges in climate predictions. But despite of these challenges, there are exciting advances. Scientists are using high-resolution models to see more local details. Artificial intelligence and machine learning are helping to improve forecast. And in symbol forecasting, where many different model runs are combined, gives a better idea of the range of possible outcomes. In conclusion, climate predictions are critical tools for preparing for the future. They allow societies to adapt to changes and reduce risk. Although there are still uncertainties, advances in technology are making predictions more reliable. So we must continue to invest in research and collaboration to build a safer and more sustainable world. So that would be all. Thank you and have a good day.